Hello everyone to the video about exercise 61, in which we have a lot of information, right? I think this may be one of the more difficult parts of this paragraph, is just when you get an exercise and they throw so many pieces of information at you and you just find yourself overloaded, right? You don't know where to start. There are so many points where I can start here. And that's also what I'm going to say before I'm going to elaborate this exercise. I'm going to do it a certain way, which I see. I'm going to use mostly corresponding angles, but there are a lot of possibilities for alternate angles here as well. And therefore there are many different ways how we can calculate the angles that they want us to calculate, right? Which are angles S2, D3 and C1. Again, you see that a lot of lines are parallel to each other, which gives us a lot of possibilities to use F angles and Z angles, also known as corresponding angles and alternate angles. As I sometimes said, if you don't know where to start, try to use the order, or try to go on the order they give you, right? So here they start with angle S2. Is there a way that I can calculate angle S2? And I'm going to sometimes draw in this drawing to show you a bit more where corresponding and alternate angles occur. For angle S2, the way I would calculate this one is, say, I'm not going to use red because it's already in that picture. If you look closely, you will see that there is an F angle, a corresponding angle like this, because this line is parallel to this line, which means that this point, this angle and this angle are the same, and this angle and this angle are the same, right? That helps us because if we know S1, we know S2 as well, because we can calculate that using the rule for a straight angle. So here, what I'm going to do, I'm now going to erase this part, right? But now you see why there is a corresponding angle here. So I can say angle S1 is equal to angle D1. And I used corresponding angles for that. Corresponding angles. How do I calculate angle S2 right now? Well, I can do 180 minus, and I can also say is equals 102 degrees, right? So this is going to be 108 minus 102, which gives us 78 degrees. And I use the rule for a straight angle. You could also have calculated the angle that's right here if I expand this and then say this is equal to this one, but this one doesn't have a name, right? So then you have to name that angle yourself. Instead I do it this way. And again, I think there certainly were ways others in this as well. I use this one. Angle D3, let's take a look. That's this one. How can I calculate that one? Again, there are multiple ways. For example, I could say, well, there's a Z shape right here, so D3 is equal to E2, for example. But how am I going to calculate E2 is my question in that case. That can take multiple steps. What I also could do is say, well, this one is maybe a bit more hidden than the previous one, but there is a corresponding angle like this right here, which means that this angle, angle A, equals angle D3. Can I calculate angle A? Yes, I can, right? Because I know angle C12 and I know angle 65, angle B. So what I could do is, I'm going to erase this drawing first so it doesn't get too messy. I could say angle A is 180 minus 65 minus 68, right? So remember, sometimes you have to calculate a smaller angle like this, you have to take a look at the whole picture again. In this case, I think it's rather difficult to see that I could use a corresponding angle there. But this is calculated using the angle sum methods, angle sum triangle, web. And now I could say angle A equals angle D3 equals 47 degrees. Right. Why? Because of our corresponding angles. The F angle. And again, this could have been done with calculating angle E2 and then using an alternate angle. Maybe some of you were able to calculate angle E1 and then do an angle sum triangle in this part. Right? I think I could have done that actually, because angle E1 is the same as angle C1 too. So, because there's an F angle here. So C12 actually equals C1 because of a corresponding angle, and then I could use the angle sum method here. Also a nice way to calculate it. D3. Okay, but this one is just as correct. The last one, angle C1. How would I do this? I can do this in one go if I wanted to. What I'm going to do is angle C1 is part of triangle ADC, like this. I know angle A was 47 degrees, and I also know angle D1, right? It's 102 degrees. And again, I guess there are multiple ways to do this. I chose this one. This is 31 degrees if I'm correct. And I only use the angle sum here. So you see the angle summed of a triangle is used rather clearly a lot here. Okay, so this is my way how I would solve 61. Are there more ways? Yes. Did you find the same values for those angles as I did? Then you did something correct, right? You did it only in a different way. There are a lot of Z angles, alternate angles here as well. For example, F2 equals E2. So maybe you could say I calculate F2, then I know E2, and then I know D2, right? That's all because there are a lot of triangles in here that have the same shape. For example, ABC is the same shape as FSC. It is the same shape as, for example, do I say that correctly, by the way? Yeah, I said it correctly. And for example, triangle right here is the same shape as here. So that means that a lot of angles are going to have the same values. If you have any questions left, please ask me in the lesson. I will say good luck to you all.